For the latest space developments, you know where to find us. The most revolutionary breakthroughs often look like small technical changes until they unlock possibilities we never imagined. When Rocket Lab announced their $5.6 billion military contract win in March, industry insiders expected the usual congratulatory tweets from competitors. But Elon Musk's response was different and revealing. Instead of his typical public commentary, SpaceX quietly accelerated Starship testing schedules and announced new manufacturing partnerships within weeks. But here's what few people realize. Musk had been tracking Rocket Lab's progress for months before that announcement. Sources close to SpaceX revealed that internal strategy meetings had already identified Neutron as the first credible threat to Falcon 9's medium-lift dominance. And here's the detail that shocked industry veterans. SpaceX's response suggested they saw Rocket Lab as a more immediate competitive threat than Blue Origin. Why would that surprise anyone? Let's break down what Rocket Lab just accomplished that took Blue Origin 13 years to even attempt. First, the engineering breakthrough that changed everything. Rocket Lab's hanging stage design. Picture trying to balance a sports car on your roof versus suspending it inside your garage. Most engineers said the suspension approach was impossible at scale. Yet Rocket Lab proved them wrong by suspending their second stage inside the first stage's fuel tank, cutting overall mass while boosting efficiency. And here's what most people overlook. This wasn't just clever engineering, it was a complete rejection of 60 years of rocket design philosophy. Every major rocket, from Saturn V to Falcon Heavy, stacks stages on top of each other. Rocket Lab said why, and built something entirely different. The numbers reveal the magnitude of this achievement. Neutron will launch with 9 Archimedes engines producing 918 tons of combined thrust. But here's the engineering challenge that made SpaceX engineers take notice. Rocket Lab initially planned 7 engines using simpler technology, then voluntarily chose the harder path when they hit thermal limits. Most companies would have accepted the compromise. Rocket Lab switched to closed-cycle engines, the advanced technology typically reserved for much larger, more expensive rockets. This decision added months to development, but demonstrated the kind of technical ambition that makes competitors nervous. But the real shock came from their manufacturing approach. Neutron will become the first large launch vehicle built entirely from carbon composites, using an automated fiber placement system that produces meters of rocket shell in minutes. When Musk tweeted about SpaceX's own carbon composite experiments shortly after, industry observers noted the timing wasn't coincidental. We'll come back to this manufacturing revolution later. But first, there's something even more surprising about how this small New Zealand company outmaneuvered both SpaceX and Blue Origin in the most competitive market segment. Here's where things get interesting. While Blue Origin spent 25 years building a 10,000-person workforce, Rocket Lab achieved comparable milestones with just 1,500 people in 7 years. But that's not the shocking part. The real surprise was how they turned this apparent disadvantage into their greatest competitive weapon. And here's what few people realize about the U.S. Space Force contract. Rocket Lab didn't just win by being cheaper or faster. They won by solving a problem that kept Pentagon officials awake at night: America's dangerous dependence on a single launch provider for critical military missions. Think about it this way. If SpaceX's Falcon 9 were grounded tomorrow due to an accident, the entire U.S. military satellite program would halt. The Pentagon needed a backup, but Blue Origin's New Glenn has been almost ready for 4 years. Rocket Lab stepped into that void with Neutron, and the timing was perfect. But there's a detail most people overlook that explains why this shocked even industry veterans. Rocket Lab's approach to reusability deliberately differs from both competitors. While SpaceX and Blue Origin chase maximum reusability, Rocket Lab optimized for rapid turnaround. Their fixed landing legs don't fold, eliminating major failure points and reducing refurbishment time between flights. The economic implications become clear when you examine their business model. Blue Origin represents the old aerospace paradigm: massive investment, long development cycles, perfectionist culture. Rocket Lab embodies the new paradigm: lean teams, rapid iteration, calculated risk-taking. And here's what's truly noteworthy. They're proving the new approach works better. Consider their operational track record. Rocket Lab's Electron rocket has completed over 60 successful launches since 2018. Blue Origin's New Glenn? 0 operational flights after 13 years of development. The contrast couldn't be starker, and industry leaders noticed. What happens if this pattern continues? We're about to find out, because Rocket Lab just made their boldest move yet, breaking ground on Launch Complex 3 before Neutron has flown even once. The 400-foot drone ship they're building with Bollinger Shipyards, nearly as long as a Starship, represents a massive bet on their untested rocket. Most aerospace companies would never make such investments without proven hardware. But Rocket Lab's confidence stems from something their competitors lack: a track record of delivering on ambitious promises ahead of schedule. And this leads to a remarkable discovery about how the space industry's power structure is shifting in real time. What we're witnessing isn't just corporate competition, it's the emergence of a fundamentally different approach to aerospace development. And the implications will reshape how we think about space access for decades. Here's why this matters beyond launch contracts. Rocket Lab's success demonstrates that smaller, more agile companies can consistently outperform traditional aerospace giants. But there's something most analysis misses. This isn't just about efficiency, it's about industrial strategy. The Pentagon has explicitly stated that American space access cannot depend on a single provider, regardless of reliability. SpaceX's dominance, while impressive, creates strategic vulnerability. Rocket Lab's emergence as a credible alternative changes the entire security calculus, and defense planners are taking notice. But here's what's truly surprising about the competitive dynamics. Traditional metrics no longer predict success. Blue Origin has more employees, more funding, and longer development timelines. Yet they're falling further behind a company that fits inside a medium-sized office building. This inversion of expectations has senior aerospace executives questioning fundamental assumptions about scale and success. The carbon composite manufacturing breakthrough alone could revolutionize rocket construction industry-wide. Traditional aluminum rockets require extensive tooling, welding, and complex assembly. Rocket Lab's automated fiber placement system produces continuous carbon sections, dramatically reducing part count and manufacturing time. If this approach proves scalable, and early results suggest it will, every rocket manufacturer will need to adapt or risk obsolescence. And here's what few people realize about the timeline pressures. NASA's Artemis program, military constellation deployments, and commercial satellite networks all require predictable launch schedules. Blue Origin's repeated delays haven't just cost contracts, they've undermined confidence in traditional development approaches. Every month of additional delay strengthens Rocket Lab's market position. Yet significant uncertainties remain. Neutron hasn't flown a single test mission. First flights carry substantial risks. Technical failures, performance shortfalls, or accidents could derail everything. Rocket Lab's willingness to invest in ground infrastructure before proving their rocket demonstrates either supreme engineering confidence or considerable financial risk. But perhaps the most important question isn't whether Rocket Lab will succeed, it's whether their success signals a permanent shift in aerospace development philosophy. Are we witnessing the emergence of a new generation of space companies that prioritize agility over scale, execution over engineering perfection? The answer will determine not just who wins the current competition, but how humanity expands into space over the next century. And based on what we've seen so far, the small company from New Zealand has already changed the conversation about what's possible when you challenge conventional wisdom with unconventional solutions. This is exactly why Elon Musk's subdued response spoke volumes. He recognized that Rocket Lab had cracked the code on something SpaceX is still perfecting: rapid, cost-effective development without sacrificing capability. What this means is, we're not just watching a business competition, we're witnessing the birth of a new aerospace paradigm that could accelerate humanity's expansion into space by decades. Rocket Lab's success represents more than market disruption. It's proof that space access can be democratized through smart engineering rather than massive capital. Their carbon composite manufacturing and agile development approach could become the blueprint for the next generation of space companies, from Mars mission providers to asteroid mining ventures. And this is just the beginning. Neutron's first flight in late 2025 will either validate this new approach or serve as a reality check. But with SpaceX quietly accelerating their own programs and Blue Origin scrambling to catch up, the next 2 years will reshape the entire competitive landscape. How do you think this rapid innovation cycle will impact NASA's timeline for returning to the moon? Will smaller companies continue outpacing aerospace giants, or is this just a temporary advantage? This is Space Hub, where we break down the engineering breakthroughs and competitive strategies that are reshaping space exploration. If analysis like this helps you understand what's really happening in the space race, consider subscribing for more deep dives. The small company from New Zealand just proved that in space, audacity and execution matter more than size and legacy. And that might be exactly what humanity needs to become a truly spacefaring civilization.